We are given the laws of nature as differential equations or maybe iterative maps. This is a short time description of dynamics. This tells us what happens for infinitesimal or short time. What we would like to understand is the consequences of dynamics at long time, even infinite time, time much beyond Lyapunov time. The connection between short and long time you're actually familiar with from quantum mechanics and other subjects. That's what Fourier transforms do. If you have some short distance information, then Fourier transform variable will tell you what happens at long distances. In this subject, the transformation comes in two flavors. One is if you have discrete time dynamics, the transformation is called a generating function. And in continuous time, you're very familiar with it because it's just a Laplace transform. Let me summarize what we have learned about discrete time dynamics. We live in some state space M, and we have partitioned it, coarse-grained it, into regions of which I only write the initial and final for the transition we're interested in. Then we are given a law of dynamics which says if I start someplace here and if I land there, that's given by my short-term dynamics in detail. But when we look at coarse dynamics, we have replaced this detail law which says how you start from the point and end the point. We replaced it by the transition matrix. This is one time step, shortest possible time step dynamics. But now we also have description of long time, which means that if I look at the state space and I explore it by trajectories of long or infinite length, which means I do something like that. I do this forever. I get totally crazy dynamics, ergodically exploring every place. This I can describe by a generating function. Z t 1 minus ct. And now this generating function, the transfer matrix has a spectrum of its eigenvalues. And clearly this thing will be divergent as long as my probability of hop is smaller than the inverse leading eigenvalue of this. This is a convergent series. And as I approach it, I will actually start sensing what happens in long time. So this gives me the infinite time dynamics. So this is how one thinks of going from, in discrete time, from one step to infinitely many steps. And the main trick is just to resum all possible paths using generating functions.